Hello, my name is Alfredo Garcia. I'm going to be presenting for you today Kinetic Molecular Theory utilizing POGIL strategies for Grand Canyon University. So I do apologize in advance. I don't have a clicker with me, so I will be having to step out of frame in order to advance the presentation. But it should only be for a couple of seconds at a time. So really quick, a background on my presentation. I wanted to incorporate POGIL strategies into teaching kinetic molecular theory at a high school level. And the background is kinetic molecular theory is a scientific theory that states that gases are in constant random motion. These particles move until they collide. These collisions are assumed to be perfectly elastic, which means no energy is lost as the particles collide. The average kinetic energy of the particles depends on the temperature of the gas. So heating the gas up increases the kinetic energy, or average kinetic energy, and vice versa. So I find that students at times have difficulty understanding what kinetic molecular theory is and how it can be applied to other aspects of chemistry because it is somewhat abstract and intangible. So students have a hard time at times being able to understand or comprehend certain chemistry topics which are kind of abstract, which they can't really observe with the naked eye or touch or feel. And because of this, I think it lends itself well as a subject in chemistry which must be explored and explained well. So if you're not able to explain kinetic molecular theory to students very well, then they may struggle further down the line with other aspects in chemistry, right? Such as thermochemistry and other things. So before we move on, I'll talk about what POGIL is and why we should apply it. So POGIL is an acronym that stands for Process-Oriented Guided Inquiry Learning. It's an instructional strategy and philosophy which centers on group learning as well as giving students a greater part in determining their own learning. POGIL is a strategy that was developed in 1994. It is a research-based strategy as there have been several studies performed on the effects of implementing it, and it is widely used today. It was also a strategy that was developed to better teach general chemistry, which makes it a perfect fit. So POGIL itself is a philosophy that centers on sort of taking the teacher out of the picture as much as possible. So getting the students to work hands-on, in a hands-on environment, while the teacher sort of kind of acts as a mediator or stands outside and enables them to learn and only steps in when absolutely needed. So for the implementation, the general implementation of POGIL involves scaffolding instruction. Students begin by exploring the desired concept. The exploration is meant to pique students' curiosity and have them ask a guiding question. The guiding question then leads to implementation of learned material in new ways. So basically, when using POGIL, what you want to do is sort of get the students curious, right? So present them some sort of material that's going to spike their curiosity, and then from there, use that curiosity, as a driving force to push the learning forward. So the students should feel curious and should want to learn what it is that they're going to be learning. And then from there, they should be able to learn and eventually, hopefully, apply what they learned in a new way or sort of create with what they're learning. So for the implementation, I have provided a lesson plan, and the lesson plan has 5 steps. So the first step is going to be a lab, which is our hot air, cold air activity. Step 2, the guided question. Step 3, research or the why. Step 4, presentation and consensus. And step 5, student-led class discussion. So let me briefly jump into what all of these steps entail. So step 1, hot air, cold air activity. The initial implementation of the POGIL strategy involves having the students ask a guided question. We will accomplish this by having the students perform a simple lab. the teacher is meant to facilitate the lab, and the lab is meant to get the students to question what causes the observed effects on the balloon. So the link to the lab is included in the presentation in case you want to take a look at it. But basically what the lab is, it's a very simple elementary lab. So what you do is you get a liter bottle, it doesn't matter what type of bottle it is, and you attach a balloon to the top of it. You then place the bottle into a warm water bath and a cold water bath. And of course, we know what's going to happen. We know that the balloon is going to expand when you put it into a hot water bath, and we know that it's going to deflate, right, when you put it into the cold water bath. And we know this is because the air gains kinetic energy and expands, adding more internal pressure inside of the balloon. But the students aren't going to know that, right? So essentially when the students see this, it's going to be kind of magical to them, right? They're going to have that wow moment where they're just in shock, right? They see a balloon being inflated on its own and they want to know why, or hopefully they're going to want to know why. So best case scenario, they're going to start asking you, sir, you know, what is causing this? Why is the balloon expanding? What leads to this? And from there, you use this curiosity to push the rest of the activity forward. So step 2 is going to be the guided question. Once students perform the lab, they should be curious about what causes the observed effects, which should lead to the question, why does the size of the balloon change? So that's what they're going to want to know. Why is it that the balloon gets bigger and then smaller depending on which water bath you put it in? So from there, you're going to get them to use this curiosity to push forward and research on their own and discover on their own what is the cause of the balloon expanding. So step 4 is the presentation and consensus. So after students believe they have come to a conclusion as to what caused the observed effects during the lab, they will present their findings to other groups to see if everybody came to the same conclusion. If not everyone came to the same conclusion, then a consensus must be reached. So the students are going to go off on their own. They're going to research what caused the effects that they observed during the lab, and they should all, in theory, come to a similar conclusion as to why the balloon expanded. But there may be some differences, some subtle differences, right, between every group as to what it was that caused the balloon to expand. So maybe one group comes directly to kinetic molecular theory, right? Maybe another group comes to realize that it has to do something with air pressure, right? So from there, what the students have to do is come to a consensus. So you want all of the students to sort of discuss as a class what they think it was that caused it and which answer they think is going to be the right answer. And a way that you can do this is with a gallery walk. So I'll briefly try to explain what a gallery walk is for those of you that don't know. What a gallery walk is simply, so students work in groups, and while they're working in groups, or when they're done working with their groups, one student is going to stay behind and present, while the rest of the group is going to walk around the classroom and be presented to by one student, the one student that stayed behind from each group. So it's somewhat difficult to explain, so excuse me if maybe I'm not able to get it across very well, but I've also provided a link in one of the slides that will take you to a website that hopefully can explain it better than I can if it doesn't make sense to you. But it's a great tool for trying to communicate a lot of data, right? So to get everybody to communicate data effectively and for everybody to be able to intake all of the data that was acquired from every single group efficiently. So the last step is going to be a student-led class discussion. So after a consensus is reached, students should discuss the implementations and applications of what they learned. The teacher can guide the discussion by asking certain questions such as what are useful ways in which to apply what we learned, or do you still have questions on your observations? An important note on this part of the strategy is that the teacher should only serve as a facilitator or guide. The discussion should be student-driven and input should be student-made. So after everybody is done presenting or being presented to, depending on what it was that they did inside of their group, what you want to do is have the students discuss what are ways in which they can apply the knowledge that they gained. And the reason why I think this is a good idea is because in order to apply a topic or content subject that you've learned to a different scenario involves somewhat of a level of mastery. So if you haven't really mastered something, it's difficult to apply it to something else. So if the class is able to present what they learned and apply it to other situations or scenarios, or try to come up with new inventive ways to use what they learned, then there's a clear level of understanding amongst all the students, which is what we're aiming for at the end of the presentation or at the end of the activity. And that is going to be the end of my presentation. Thank you for your time.